This is the EdExcel AS Level Maths Paper 2 covering the Statistics module, and this is from the 2022 series. Question number 1. The relationship between two variables p and t is modelled by the regression line with equation p equals 22 subtract 1.1t. The model is based on observations of the independent variable t between 1 and 10. For part A, we have to describe the correlation between p and t implied by this model. Well, what we know for part A is p equals 22 subtract 1.1t, and therefore what we have is a negative correlation, and that's because the gradient of the regression line is negative. So because we've got a negative gradient, we have a negative correlation. Given that p is measured in centimeters and t is measured in days, for part B we have to state the units of the gradient of the regression line. Well, for part B, we know that p equals 22 subtract 1.1t. Now, we know that p has units centimeters and t has units days. And for us to end up with units of centimeters, what I need for the units of the gradient will be centimeters per day. It's as though the days cancel here and here, leaving us with units of centimeters, and therefore the units are centimeters per day. Next, using the model, we have to calculate the change in p over a 3-day period. Now, in this question, what we cannot do is substitute in 3 for t, because we are concerned with the change in p over a 3-day period. If we draw a number line, such as the one we see here, the values of t go from 1 to 10. And what we have here is a 3-day period. So t could go from 1 to 4, for example. It could go from 6 to 9. It could go from 3 to 6. Or it could go from 7 to 10. We don't know the specifics of the 3-day period. All we know, we have some sort of a 3-day period. And therefore, to calculate the change in p over a 3-day period, what we would have to do is consider the negative 1.1 multiplied by 3. So, because we have a 3-day period, what we would have to do for part C is multiply 3 by negative 1.1, and of course that will equal negative 3.3, and therefore we have a decrease of 3.3 centimeters over a 3-day period. TISAM uses this model to estimate the value of p when t is 19. We have to comment giving a reason on the reliability of this estimate for part D. Well, for part D, we see that 19 is outside the range 1 to 10. And so if we were to use 19, we would have to use extrapolation. And so therefore, we have something which is possibly unreliable. Question number 2. A manufacturer of sweets knows that 8% of the bags of sugar delivered from supplier A will be damp. A random sample of 35 bags of sugar is taken from supplier A. For part A, using a suitable model, we have to find the probability that the number of bags of sugar that are damp is, for the first part, exactly 2, and then for the next part, more than 3. We begin by letting D equal the number of bugs that are damp. Now, we have a binomial distribution, which means D is binomially distributed with parameters. Now here, we have 35 bugs. We've got a 0.08 chance of the bug being damp. So our parameters will be 35 and 0.08. And so for the first part, we have to find the probability that D is equal to 2. And if we find out what this is, well, from our calculator, if we go to the distribution sub-menu, select 4 for binomial PD, number 2 for variable, x is 2, n is 35, p is 0.08, and it turns out to 3 significant figures, we end up with 0.243. And then, for the next part, we have to find the probability that D is greater than 3. Well, what this is the same as is 1 subtract the probability that D is less than or equal to 3. So, from our calculator, if we go to the distribution submenu, then select binomial CD, number 2 for variable, x this time is 3, n is 35 and p is 0.08. So we have 1 subtract 0.6939, etc. So 1 subtract this is equal to 0.306 given to 3 significant figures. Supplier B claims that when it supplies bags of sugar, the proportion of bags that are damp is less than 8%. The manufacturer takes a random sample of 70 bags of sugar from supplier B and finds that only 2 of the bags are damp. We have to carry out a suitable test to assess supplier B's claim. You should state your hypotheses clearly and use a 10% level of significance. Now, for part B, if we let x equal the number of bags that are damp from B, we have a binomial distribution, so x is binomially distributed. This time, what we were told in the question is we've got a sample of 70 bags, so we've got 70 and 0.08 for our parameters. Our null hypothesis H0, we have P equaling 0.08, but then for our alternate hypotheses, well, supplier B is claiming that the proportion of bags that are damp is less than 8%. So we have P being less than 0.08. And what we have as well is a significance level of 10%, which is equal to 0.1. Now, what we found was that there are only 2 of the bags which are damp. So what we need to do is find the probability that x is less than or equal to 2. So if we work this out, from our calculator, if we go to the distribution submenu and then binomial CD, variable x is 2, n is 70, p is 0.08, and therefore the probability that x is less than or equal to 2 is equal to 0.0740, and this is given to 3 significant figures. And so we've got our significance level 0.1. We have found our probability to be 0.0740, and therefore we are in the region where we would reject H0, which means that there is sufficient evidence to support B's claim. Question number 3. The diagram summarizes the heights of 256 seedlings 2 weeks after they were planted. So we've got the height of the seedling in centimeters and the frequency density. For part A, we have to use linear interpolation to estimate the median height of the seedlings. So for part A, let's begin by creating a table. We've got the class, frequency, and the cumulative frequency. Now for our class, first of all, we've got 0 to 1, then we've got 1 to 2, then we've got 2 to 3.5, then we've got 3.5 to 4.5, then we've got 4.5 to 6.5, and then we've got 6.5 to 8. We now need to find the frequencies, and we can find the frequencies by finding the area. So here we've got 1 multiplied by 15, that's 15. Then we've got 1 multiplied by 35, which is 35. Then we've got 1.5 multiplied by 50, which is 75. Then we've got 1 multiplied by 55, which is 55. And then we have 2 multiplied by 26, which is 52. And then we have 1.5 multiplied by 16, which is 24. We are now in a position to find the cumulative frequency. We start off with the 15. 15 plus 35 is 50. 50 plus 75 is 125. 125 plus 55 is 180. 180 plus 52 is 232. 232 plus 24, that's 256. We can now use linear interpolation to help us find out the median. Well, we've got 256 pieces of data, and because we are finding the median, what we would have to do is 256 divided by 2, which is equal to 128. So we want the 128th value and the 128th value will lie in this interval over here. Now the next thing to do is create a line segment. Now we want to find out the median, and the median will be the 128th value. And let's call the median Q2. Now we've got 125 pieces of data, which is 3.5 or less. So for our lower, we have 125 and 3.5. For our upper, well, we've got 180 pieces of data, which are 4.5 or less. So we have 180 and 4.5. And now at this point, we can recognize that the gradient of this line will be the same as the gradient as this shorter line. And therefore, we have Q2 subtract 3.5 divided by 128 subtract 125. This is equal to 4.5 subtract 3.5 divided by 180 subtract 125. And from this we can find out what Q2 is. So if we find out what Q2 is, well, we have 4.5 subtract 3.5 divided by 180 subtract 125, and then I multiply this by 128 subtract 125, and then I add on 3.5, and it turns out to three significant figures. The median is equal to 3.55 given to three significant figures. Chris decides to model the frequency density for these 256 seedlings by a curve with equation y equals kx multiplied by 8 subtract x, where x is in between 0 and 8, and k is a constant. For part B, we have to find the value of k. Well, if we integrate y, we will get the frequency. Integrating the frequency density function will get us the frequency. And so therefore, for part B of the question, if we integrate between 0 and 8 the function y, which is kx subtract multiplied by 8 subtract x with respect to x, and if we set this equal to 256, which is the total frequency, then we can find out what k is. Now if I take k outside of this integral because it's a constant, we've got k multiplied by the integral from 0 to 8, and if I multiply out x by 8 subtract x, we end up with 8x subtract x squared dx, and this is equal to 256. So we have k, and then I'm going to multiply this by, well, if I integrate 8x, I end up with 4x squared, and if I integrate x squared, I end up with 1/3 x cubed. And I'm evaluating this between 0 and 8, and the result of this is equal to 256. So we've got k multiplied by, well, here we have 4 times by 8 squared, subtract 1/3, multiplied by 8 cubed, and this is equal to 256. So we end up with 256k over 3 equals 256, which means k is equal to 3. Now, for part C, using this model, we have to write down the median height of these seedlings. Well, the median will be the middle value. And if we consider the symmetry of this quadratic function, it's symmetrical about x equals 4. And therefore, for part C, by symmetry, the median is equal to 4. Question number 4. Zhang is studying the variable daily mean pressure from the large dataset. He drew the following box and whisker plot for these data for one of the months for one location using a linear scale, but he failed to label all the values on the scale, and he gave an incorrect value for the median. Now he's given this median as 1200 for the daily mean pressure. Using your knowledge of the large dataset, we have to suggest a suitable value for the median and then the range. Now, you are not expected to have memorized values from the large dataset. The question is simply looking for sensible answers. Now here we've got the large dataset, and what we are looking for is information about the pressure. And we know for pressure, the mean sea level pressure has been calculated from a measurement made at a station level. Now, if we take a look at the daily mean pressure for the various locations and years, what we see here is we've got values of around 1020, and that's the same for the various locations. We've got values of around 1020. Some are above and some are below. And you can see as I flick through the various tabs of the large dataset, we've got values around 1020. So for the median, instead of 1200, what I would expect is a median of around 1020 HPA instead. And then when we take a look at the range, well, for these different values, we've got smaller values such as 1018, and then we've got larger values such as 1031, and this is for Perth, for example. Now, if we take a look at some of the UK locations, we've got 1016, and here we've got 1020. They are around about 1020 here. And if we take a look at some more, like Heathrow, we've got 998 for a smallest value. We've got values such as 1013 and so on and so forth. Here we've got 1015, here we've got 1027, here we've got 1022. So what I'm expecting for the range is to have a value of around 30. I'm expecting the values to range from somewhere between something like 1000 to 1030. So a suitable range for part B will be 30 HPA. So what I would advise in this sort of question is to familiarize yourself with the range of values for the various different tabs and gain an understanding of how, say, temperature varies in various locations. Question number 5. Manon has two biased spinners, one red and one green. The random variable R represents the score when the spinner is spun. The random variable G represents the score when this green spinner is spun. The probability distributions for R and G are given below. The probability that R equals 2 is a quarter. The probability that R equals 3 is 3/4. The probability that G equals 1 is 2/3. The probability that G equals 4 is 1/3. Manon spins each spinner once and then adds the two scores. For the first part of part A, we have to find the probability that the sum of the two scores is 7. So we want a sum of 7. How could we get 7? Well, adding 3 to 4, we get 7. Which implies, for the first part of part A, that R equals 3 and G equals 4. So, what we can say then, the probability that the two scores is 7, well, the probability that R equals 3 is 3/4. The probability that G equals 4 is 1/3. And therefore, the probability that the two scores is 7, this is equal to 1/4. So the probability that the two scores is equal to 7 is 1/4. Then we have to find that the sum of the two scores is less than 4. Well, how could I get something less than 4? Well, I could have R equaling 2 and G equaling 1. 2 plus 1 is 3. That's certainly less than 4. So for the next part, we have R equaling 2 and G equaling 1. This gives a score of 3, which is less than 4. And so, the probability that the two scores is less than 4, well, we've got 2 plus 1, which is 3. So the probability of scoring a 2 is 1/4. And then the probability of scoring a 1, that's 2/3. and therefore what we end up with is a quarter times 2/3, which is 1/6. Now, the random variable x equals mr plus ng, where m and n are integers, we've got the probability that x is 20 is a sixth, and the probability that x is 50 is a quarter. We have to find the value of m and the value of n. Now, first of all, for part B, we've got the probability that x is equal to 20. That is equal to 1/6. Now, if we've got the probability equaling 1/6, as we see here, this will imply that r is 2 and g is 1. So, this will imply that r equals 2 and g equals 1. And if I substitute that in to here, we've got x, which is 20, r is 2 and g is 1. So forming an equation in that case, we see that 20 equals 2m plus n. And we've also got the probability that x is equal to 50, equaling 1/4. Now, we've got the 1/4 here, and we found that when we've got a quarter for our probability, that would mean that r is 3 and g is 4. So, x is 50, and with our values of r and g, we would have 3m plus 4n. Now, if I call this equation 1 and this equation 2, what we can do is solve those equations simultaneously. So, we've got 2m plus 1n equals 20, 3m plus 4n equals 50. We see that m is 6, n is equal to 8, and that's what we needed to find out.